Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. Welcome to the show. It is April 25th, 2025. Welcome. We got our usual panel on. We got Ben in the background. We have Lulu.
How you doing, guys?
We got Lulu and we got Mr. Phillip on. Live chat is open. Any questions, comments for the panel tonight? Let's light up that chat tonight. And we got our usual crowd showing up to the show tonight, so that's great. And we'll get right into it today. I've been basically ordering parts for that off-the-grid project I'm doing it for a friend of mine. He wants me to build a unit that's in a box with wheels on it and a handle, and you can take it camping with you. So take it camping, you can use it and cook, your electrical devices on it, your induction cookers and stuff like that. And lighting and maybe a small heater and stuff like that. You'll have a solar panel with it. So I'm just piling up all the parts here. The box is supposed to be coming in Monday, so I hope Monday I get the box. I had to order it from Home Depot, but I could only get it online. So I have to wait for the shipping for them to ship it to the store. And then when it gets to the store, then they'll call me up and I can go pick it up. So a little bit of a waiting game, but I've got most of the components now. And I'll be starting that build soon. And I'll also be posting all the build videos. So we got Bernie out there. He says he's going to be joining us in about an hour's time. So that's cool. I want to start the show with a video first, and then we're going to jump right into Phillip because Phillip is going to kind of carry on with this. And so basically years ago, back when J.J. Thomson and he was coming up with the electron and all this, Tesla had an issue with it. He didn't believe the electron theory. Now, speed up forward to 2025, I managed by chance to see this interview with Mr. Neil deGrasse Tyson and this physicist talking about the electron. So I want you guys to listen to this, and this kind of goes back to what Tesla kind of felt about the electron. So with a little bit more detail, with a lot more testing and engineering over the last 125 years, this guy seems to be quite on the mark with what he feels that the electron is. So I'm just going to do a screen share here. Okay, here we go. Can you guys see my screen?
Yep.
Okay.
Ask you a blunt question, which sounds stupid, but I think it's a meaningful question. Do electrons exist? As
now, wait, is that a science or a philosophical question?
Well, because
natural philosophy.
As I understand it, we have never measured the size of the electron. It is smaller than the smallest capacity we have ever conjured to measure its size.
Okay, I got to ask you a preliminary question. How truthful do you want me to be?
I love it.
Okay, give me what you say in the back room. In the back room with the cigars.
No, let's lie to me. Then tell me the truth.
Okay.
The lie is,
yes,
what is real is the electron field. And little vibrations in those electron fields show up in our detectors as particles. So it's not that we haven't measured the size of the electron, it's that there is no such thing as the size of the electron. The electron is a vibration in a field. It can have different vibrational wavelengths.
And it shows up as the particle.
Yes, that's right. Yeah, that's right.
I mean, it comes to the party that way, but otherwise it's not.
Yeah.
Okay, that is trippy.
Wait.
That is so freaky, man.
Wait.
So you and Einstein both were bothered by this.
Yeah, I am very bothered by this.
Wait, so you cannot measure the electron in its wave state to be a particle, because the act of measuring it turns it into the particle.
The way that we usually measure things, you say, where is it? and you get a little track in your particle detector because you keep asking where it is, and you always get a definite answer to the question, where is it? But when you're not asking that question, it's spread out all over the place.
Let me ask you a blunt question, which sounds.
So, what do you guys think of that?
Yeah, that's awesome.
Well, yeah, I mean, it's a point particle, like they call it, because it has. They can measure. They couldn't measure its radius.
Right, because it's a field. It's a coherent field.
Yeah.
Which creates a shape, and our detectors can detect it. And when you see it, it looks like a particle, but it's not. It's actually a field that looks like a particle, but it's not a particle. Yeah. So Tesla is very, very correct on this, saying an electron is not a particle energy. It is a field. And I think Farnsworth, the guy who created the TV, from what I heard in one interview with Eric Dollar, because he knew the Farnsworth family, Farnsworth knew what the electron was, but he never wrote it down, and he never revealed the secret on what the electron actually is. And I think it's pretty obvious now because so many years passed, right? We got better equipment, better detection equipment to prove that the electron is not a particle.
Yeah. Yeah, I wanted to say something, I forgot, but the electron, like I was saying earlier, it's some sort of, it's not like it's not like a ball of pool. You know, people think it's like a ball of pool, but that's not what it is at all. It's some side effect of a virtual particle that
it's waves. It's like
it's like a wave.
Yeah.
Same thing with the positron. And when the electron and the positron are entangled together, it creates a photon with kinetic energy. That's why it moves, like I was explaining a couple of weeks ago.
Right.
So, but because if you calculate the mass or the energy, the mass equivalent of a photon, it's if you wanted to split to if you want the photon to split by the pair production, you need very high energy photon to produce an electron and a positron. So you have the proof right there. That's what the photon consists of. It's really a packet of energy, neutral packet of energy.
Right. Okay. So like what we were talking about before we went on tonight. So you have the electron. You have electricity. Okay. So according to Eric Dollard, and I've studied his stuff quite intensively for the last probably 10 years. You need, in order to create electricity, is what we call electricity. It needs two components: magnetism and dielectricity. With those two components combined, it becomes a hybrid, like he explains. And that hybrid becomes electricity. Now, also in that reaction too, when conditions are just right, it can emit a photon. So that means there's a component within the photon with the reaction with electricity will not only give you electrical power, but it will also emit light. So I think it's a combination of particles coming together at once to create either a photon or create electricity that emits a photon. So,
so the electron, positron, and photon, they're very similar. Now you're adding the dielectrics and the magnetism. I'm going to study that.
Right. So when you get the dielectricity and the magnetism, that's what we call electricity. Now, if it adheres or couples with anything that's a metal, like a metal wire. Now you've got the electromagnetic field now, okay? And because you got the electromagnetic field, any freestanding electron, I hate using particle because it's not. It's a coherent field of energy.
Yeah.
When you have a wire that's now magnetized with an electromagnetic field, any other of those particles, I hate using that are around the wire are now going to be coupled with that wire. And that's why we create an electromagnetic force around the wire, right? And the more of those virtual particles of electrons hitting the wire, going through a wire, and depending on the length and the diameter of the wire, that wire will now emit heat, right?
Yeah.
So
The resistance.
there's resistance in the wire, and the compiling of all those electrons on a very small area. And the more electrons that you get focusing in the magnetic field and being coupled with the wire creates your current. That's where all the current and the heat comes from. So I think I'm pretty close to the mark there on that, because it's you have to separate every single particle and its components and find out what the relationships are, what makes electricity, what makes a photon, right?
Yeah.
What makes an electron? What are those separate components when you put them all together that create what we call an electron or electricity or a light?
But I was studying voltage also a little bit this week. Voltage, yeah, we all know it's a difference of potential. It's joules per coulomb.
So the actual real definition of voltage is the rate of energy that is consumed by the circuit. That is actually came from Eric Dollard. I pounded that one into my head over and over and over again. It is the rate in which electrical energy is consumed by a circuit. That's what voltage is.
The rate, yeah, it's a voltage divided by resistance equals current.
Right.
So that's like a rate of energy that is consumed by the resistance.
By the circuit, right. Yeah. So it's the rate of energy that is consumed by the electrical circuit. That's what the quote unquote definition of voltage is.
Yeah.
Right.
Wouldn't that mean like the circuit is different? Like it would. All right. I have an idea.
Because any electrical circuit, especially say like a coil wire, it has capacitive value, right? So you could store some actual energy in that coil. That's why you get all that coil in the back EMF coming back in that coil, because there's mass there, right? That's why Joseph Newman, he was making rotors that weigh 4 tons. And he was moving it with just voltage potential, not current. He had about 50 or 60 milliamps going through that circuit into a very large mass, such as his rotor that he made for his, what he called Big Eureka. And he was able to move, a 2.5 ton rotor with 460 volts DC at about 50 to 60 milliamps. So it's all voltage, no current. So the big question was, where was he getting the energy?
Yeah.
Inside the coil. Inside the coil, he was creating a huge magnetic field, which creates an electromotive force. When you have an electromotive force, it can do work. So therefore, all he needed was voltage. The current and the back EMF from the spiking of the spark gap while it's running creates that inductive reactance in the coil, giving it even more electromotive force in the coil that enables you to move a 2.5 ton rotor. Okay. So everybody's thinking, oh, Well, it's the power output that he was trying to get over unity. No, it wasn't the power coming out of the machine. It was the physical, mechanical power that he was creating. That's where the over unity was in the Newman device. It wasn't from the back EMF pulses that were coming out like a Bedini motor or whatever, or even like my motor. His gain was on physical motive force created by that rotor. You got a 2.5 ton motor and it's spinning at 400 or 500 RPM. Try to stop it with your hand. You couldn't do it. It would throw you across the room.
Yeah.
You have so much motive force there, 2.5 tons behind it, and you cut the power off and you try to stop it with your hand, it'll throw you right across the room in a second.
What's a 2.5 ton rotor used for? Like ships, big.
Oh, sure. Huge induction motors, factories might use them,
Okay.
but he was proving the point that he was able to get his over unity based on electromotive force. That's the actual torque of what the motor was able to create with a high voltage, but a very low current, right? So he got a small motor that was 12 volts DC, ran it off a car battery, okay, at full tilt. That little motor burned out within, I think it was 40 minutes, and it started to smoke, okay? But his big Eureka is running on those little tiny 9-volt batteries for over 5 hours before the batteries died. And to boot, the device he was moving with, those little 9-volt batteries, weighed 2.5 tons. So what's over unity? That little 12-volt motor with a car battery, or his giant rotor that weighed 2.5 tons? So it was pretty much conclusive that he had an over unity device. And the U.S. patent office, he had the best engineers in the U.S. test that thing. You had guys from MIT, U.S. patent office. He had these high level electrical engineers with pretty much all the credentials you would want in an engineer, and they couldn't disprove his machine. They said it's doing what it's doing, and still in federal court they still denied him this patent. So that's the state of our world.
Yeah, I'll show you later that the academia, mainstream academia, they have way too much power over experimental physicists or experimental anybody, because we're doing this. I'll show you later. I already showed it. I already talked about it, but I'll remind people later that the experiments are not representing the predictions from the textbooks at all regarding the my liquid metal vortex that has a stronger force than what the textbooks are predicting, and I've got the exact same factor, the exact c square. It's the amplitude of the shift between the experiment and the academia is a factor of c square. So the academia is off by a large factor a lot of the time, and that includes the vacuum catastrophe. Also, that is a huge unsolved mystery that they can't explain still up to these days, and it throws off academia upside down, and the academia says, "Oh, it's no big deal." Of course, it is a big deal. It just overthrows your whole general relativity upside down, and you say it's no big deal. I mean, it's even if you prove them they're wrong, they're still gonna be
Yeah.
ongoing with their agenda.
Yeah, exactly. You're going to have a fight. Yeah. And that's to be
Yeah.
expected. That's what's been going on for the last 125 years. So
Yeah.
it's nothing new as far as I'm concerned.
Yeah, like I was saying the other day, since 1940, the peer review system started. They started peer reviewing journals like manuscript in a way that favors the conservative, not the political conservative, but the conservative mindset in the mainstream academia since 1940. So and it's every year it's getting worse. So imagine in 2025 how
Right.
bad it is. You know, it's like exponential.
Yeah.
And
Yeah.
What they
yeah,
don't to factor with the academia that it's evolving. It's not just the same old classical method of what uh, uh, science is, or researchers or scientists. Like they're stuck on the old way, that they can't see that like sometimes the stuff that we talk about is it gives them a topic to teach at school. You understand? It doesn't exist right now. This is so what is academia? They take it from somebody that actually experimented, got results, and then they somehow, manufacture it to a product that's called education for a degree, and then they, teach it to students. But things are timeline evolves, and you can't tell me that the teachers currently or professors are teaching things that are just based on old methods, because these students are going to at one point graduate and create their own.
no, it's not based on the theory is based on the old methods, yes, but not the equipment. They're very happy when they have new equipment in their lab and they're fine tuned. It's all specialized equipment, but the roots, the theory, the roots of their theory is it's completely outdated. They don't want to admit it's wrong, so they're very conservative in that sense.
Yeah,
I,
they're just trying to protect their funding and their
yeah, they
schools and
they
all that.
they
And
they create.
it's blocking the real science from progressing forward because they're worried about if their funding's going to get cut off or not because they're going
Yeah, exactly.
over a barrier.
So write them the new values. I mean, this is what, right? I mean, they're getting funding for equipment, and they're testing these theories, and they're coming out with something different. Then, like, why do they need the equipment if they're not going to publish what they find?
Well, they'll publish only what they need to publish.
Yeah,
If
they
there's
cherry
real
pick.
if there's real breakthroughs going on, and it gets reviewed by, say, the professor of the laboratory, and he says, "Okay, this is going to cause us some issues where we could lose some funding here."
Yeah,
He'll stop you right there and say, "Okay, this is going to get pushed aside. We're going to work on this, and we're going to still say that we haven't figured it out yet."
yeah.
Therefore, we know that next month's paycheck is coming in.
It's not like that in all department of the academia. Computer science is not like that at all. But that's theoretical physics. They for some reason they chose that field to block, probably because it is the most powerful. I think if we unblock theoretical astrophysics, then we will move forward and pretty fast. And if we convert theoretical astrophysics into what computer science is right now, they will move in fast, and there's a lot of the jungle in computer science
Yeah.
right now.
See, computer science is not a threat to big energy production. They're
Yeah.
worried about the energy production. That is
Exactly.
the territory that the elites do not want us to go into because they want to control the energy of the world.
Exactly.
Right? Where computer science, it's a free for all. Here's your money, go crazy. And
Yeah.
look at the gains that computer science has made in 20 years. It is fascinating what they've done in 20 years.
The computer scientists created the internet boom in the 90s, and now the AI boom.
AI
And
is just going to
now we're about to change astrophysics. And well, I am about to kick in the butt the astrophysics academia, and um, uh,
Like with Phil, I think radio astronomy, it still requires computer science in order to read the values of the data that like, let's say the planet is receiving through its little dish, well, that still requires computer science, and still requires, in order to see that wave, that and how far it is, still software. Like you have to have it to the power of so many, like what have you reached, the peta, was it the 23 or
oh yeah, but I made a mistake. I'll talk about that later. It needs to be measured because it's based it's based on the academia theory. It doesn't work. It doesn't work. I tested it already with the liquid metal vortex, and it doesn't work. I'm not getting what the theory predicts at all, by far, by c square, by the amplitude of the speed of light squared, which is 1 times 10 to the 17.
17? Okay, so 10 to
1 times 10 to the 17, which is a huge factor, a huge difference. And I'm going to talk, well, I might as well talk about it right now, if you don't mind.
no, go ahead.
Yep.
Yeah.
Let her rip. Your little intro. I don't hear any sound. Is there sound in what you're showing? Oh, okay.
Yeah, my speaker don't work. That's why I have earphones and earplugs. Sorry, and anyway, but yeah, that's my cool little graph here about the liquid metal vortex, MHD vortex. You can see if you spin it in one way, you're gonna get a gravitational acceleration that is slightly greater than the current one, and if you spin it on the other way, you're gonna get a gravitational acceleration that is slightly lesser than the average one. But what I want to talk about tonight is historical, because nobody is able to figure what gravity is, and it's been like all the brains on the world can't figure out what gravity is. I mean, I did figure it out a while ago, but now I just connected the dots recently in the last week, so that I can put it in the right, using the right words. So if we take the time dilation here, the time dilation, the gravitational time dilation, which is a variation of this equation, but I'm using this one because it's easier to understand. It's actually this is the equation 8 here is the mainstream gravitational time dilation equation, which is exactly the same as this one, but this one is the variation of my theory that is easier to understand. So this is the gravitational time dilation with respect to position. So wherever you are in altitude on Earth, you're gonna have a different time dilation. So according to my theory, the speed is the reciprocal of the time dilation. So wherever you are on Earth, your clock will go at a time rate that is the reciprocal, the inverse of the time dilation. So you're gonna end up with a graph like this. This is where x is the altitude, the blue curve is the time, and the red curve is the speed rate. So you have time rate and speed rate, which is the one is the opposite of the other. So what is the link? And don't forget, time dilation is directly proportional to the energy density. So the closer to the surface of the Earth you are on the left, the greater the energy density will be. So the time rate will be slower, and the speed will be faster because it's the opposite. So so what is the acceleration then? The acceleration is just the differential of the speed. That's all it is. So if we take the acceleration here, which is the differential of the speed, I'm getting this graph, but to get to this graph, I need to add a c-square factor. And if I add the c-square factor, then I get exactly the minus 9.8 meters per second square acceleration on the surface of the Earth. So this is what gravity is. It's the gradient or the differential of the time dilation, and ultimately, and time dilation is proportional to the energy density. It's very simple. Acceleration is it's you see the speed with respect to position is different. So you take the differential of that, and you get this acceleration curve right here. So it's very simple to understand. It works. It's an equation that works for the Earth, the Sun. This is the acceleration, the gravitational acceleration on the surface of the Sun.
Right. So, an example, the gravity on the sun is going to be a lot greater than Earth.
Yeah.
And we've also proven it too with the size of the moon relative to the Earth. So if you're on the moon, you're going to weigh about 30 to 40% lighter on the moon than you would on the Earth based on the mass of the planet.
Yeah.
And the amount of virtual particles that are bombarding that large body that creates, it's like putting your hand out the window of a car when you're driving. You feel the wind force hitting you. While going through, that's the same thing on the atomic scale with virtual particles going through the universe, and we're traveling on the Earth at 1,000 kilometers an hour rotating, and then our planet is going like over 160,000 miles per hour around the sun. So all that matter that's in space, the Earth is being, is creating almost like a wake with all these particles going through the planet. So our body is physical mass. So if we're getting hit by virtual particles traveling at 120,000 miles per second and hitting us, we don't feel it. We feel gravity, right? They say gravity is one of the weakest forces in the universe by definition. But if you're on a body that's traveling thousands of miles per second through space, those little tiny virtual particles actually amount to something which will create our physical weight. So I don't know if I'm close, or am I off on that? Is that a fair argument, Philip?
I want to ask something.
Yeah, go ahead.
Isn't okay? Like time is dependent on also something called gravity wells and the topography of like our globe, because gravity wells aren't stable. They you know they like it's like a heat signature, you know like the magma creates gravity wells in certain points. Well, when that happens, our atomic clocks that are on the surface of the earth, this is where the time dilation plays, like so an hour sometimes is not the same as an hour. Some people might feel like, oh, an hour went by so fast, and others might feel like an hour, man, like the hour's not over yet. Well, it has to do with if there's a gravity well underneath, our like underneath the planet, the surface of the earth, you know
Yeah, the gravity well. That's exactly what I'm talking about right here. It's the energy density is denser in the gravity well, and it creates time dilation, and the gradient of that time dilation difference is the acceleration, creates an acceleration. And what I want to say also to Mike is that, and I understand what he's talking about, um, but what I'm talking about here is all relative. I'm not talking. I know the galaxy is moving in the cluster, and the cluster is moving in the supercluster, and supercluster is moving in the universe. I know that very well. I studied that. I worked on that before.
Yeah,
And
because like when you're on a planet, it's all relative to you. We don't feel ourselves moving 100, 1,000 kilometers an hour as there spins. We don't feel it. It feels relative to us because we're on a large body, right? So
yeah,
we don't notice it. And the planet is traveling over 160,000 miles per hour through the universe, going around the sun. So, if 1 year in space, our Earth actually makes one orbit around the sun. We don't feel it. Everything to us, when we're sitting here right now, feels relative. So we
exactly.
don't notice it, right?
Yeah, it's all relative. But I know what you're talking about. If we have something, there's no absolute point in the universe, because if it's consider it's a thought experiment here. If you have a lonely star in an empty universe, can it spin? Can the lonely star spin? No, it can't. It can't spin because it has no frame of reference.
Right.
It creates its own frame of
Exactly.
reference, so it
Right.
can't spin.
It becomes ground zero.
Yeah, exactly. Because it's
It
the
becomes
most
ground
massive.
zero. So
Yeah,
we all know we're not ground zero. So
yeah,
that's where Eric Dollard was correct in his theory, saying, this cup of water or cup of coffee has a lot of energy behind it. So if we were able to have a frame of reference of what we would call zero or ground, okay? So we're traveling through space at 160,000 miles per hour. If I drop this off the train, it's going to make one hell of an explosion. There's so much
yeah,
energy in even our bodies. If we were to go to ground zero, get thrown off the train, we would destroy probably 3 cities. That's how much power is behind us. So,
yeah.
but we don't feel it because everything is relative because we're on a large body. We don't notice the us moving through the galaxy, right? We don't feel it. Everything's
Exactly.
relative,
It's all relative.
right? But
That's,
on the atomic scale, there's a lot of stuff going on,
yeah,
right? We the only way we feel it is by physical gravity, right?
exactly.
That's our only reference to know that we have mass is because we feel it, right?
Yeah, exactly.
Bernie's joined us. He's walking around.
Yeah.
Somewhere.
I just want to add also that the C square factor that comes out of nowhere is the exact same factor that I need to add to the gravitomagnetic permeability to get the observed um, acceleration that the liquid metal vortex um, we measure. So I need, if we take the theory says that the gravitomagnetic permeability is very weak, but experimentally is very strong because you have to plug in that C square amplitude number that comes out of nowhere, and it's pretty strong. That's why the my liquid vortex MHD liquid metal vortex works. It's because of that C square factor that we need to add, that I need to add to get the right acceleration. So it's a factor that comes out of nowhere, but it works experimentally. It works. It contradicts the physics textbooks, but that's the way it is. You can't argue with the experiments.
Yeah.
What
The Michelson and Morley experiment that they did, and they said, "Oh, well, the ether drift doesn't exist," and then experiments were carried on later by other engineers, and there is an ether drift. So the ether does exist. I think the ether is very much a big part of what we call gravity. That's
Yeah,
just
but that's because the ether for me is the gravito-electric energy layer that is emitted by the Earth,
right.
the Sun, the Moon, the planets. So they're all relative. That's why we can measure it, because it's all relative. But there's a way to measure it, and it's aboard the International Space Station, because it's kind of in between multiple bodies.
Right.
And I
Yeah,
already
that makes
calculated
sense.
that in my paper.
Yeah, I think you know what, to prove a lot of these theories, I think half the problem is how the hell do you measure it?
Yeah,
Right? What do
but
we use?
yeah, and I was accepted by the International Space Station to do my experiment, but they wanted me to pay $500,000. So obviously, I don't have
It's a lot.
that amount of money right now. But
Yeah. Yeah, half a mil's not
yeah,
exactly pocket change.
so yeah, there you go. That's history in the making right here. Nobody is able to explain gravity. I'm telling you what it is. It's the differential of the time dilation. Very simple. And time dilation is proportional to the energy density. Plus, you need to add that C square factor here, and you get the exact same values that are observed. So
Very
so
good.
yeah, that's
Awesome. Yeah, that's great. That's a really good yeah, I know some people joined late, so later on the show will be posted. So be sure to do a rewind of the beginning of the show, because there's some interesting stuff that we've talked about. And
can
also,
we can you post the Patreon link in the public chat?
yep, I did your
Thanks.
Patreon there. I got it posted. And I also have it up on the screen right now. So if you want to support Philip, you can become part of his Patreon. And also, I got my links up there as well.
Yeah, and I just explained to you guys what gravity is. So don't get fooled by these physicists. Oh, we don't know what gravity is. It might be.
Yeah.
It might be gravitons, or it might be the space-time curvature. It's all. They
It's all
can't figure it
BS.
out. It took them to 100 years, and they still can't figure it out. So
Yeah.
I'm just telling you what it is right now. So
I think Tesla figured it out too. And there was supposedly a paper he was going to release called his dynamic theory of gravity, but that never came out. It was already too late for Tesla, and he was pretty much shadow banned by the international scientific community at that point. So he was pretty much out of the picture. He was doing a lot of stuff behind the scenes, pretty close to close to when he passed away. But he was pretty much shadow banned, shoved under the rug. I do believe he had some theory written down. It would have been nice if he actually would have published it. I would have liked to have seen that. So
they
it's one of
probably
those things we will never know, right? Maybe it was part of those documents that John Trump took from his hotel room after he passed away. Maybe that theory was part of the papers there. So,
or maybe some of his paper got destroyed or something like that.
I think it just got scooped up by the government. John Trump went through it all and put that paper that he wrote on gravity and put that as top secret. So, which it wouldn't surprise me if he did.
So thanks for your time. It's
no
it
problem.
was an intense week this week when I figured it out shortly after your show last week. And I fine-tuned the equations yesterday.
Right.
And now there you go. So the C-square factor between the experiment and the textbooks are happening in multiple occasions. So don't trust the mainstream too much.
Yeah, I think so many people have got discouraged by the academia and what they've done over the last 100 years, and that Donald Trump it wants some of his stuff that his uncle was working on to come out, and there was actually a hearing on it that they want some of this either anti-gravity stuff coming out or some free energy secrets coming out that Donald Trump's uncle John Trump was working on back in the early part of the 20th century. So, and apparently he's seen some of the stuff. His uncle actually showed him some of the devices he was working on. So Donald Trump was actually a witness to some of this stuff. So we'll see what happens with that. I hope something comes out. Something. Give us something.
Maybe that's why. I'm not gonna name his name, but my good friend from Japan knows Donald Trump, and maybe that's why they're friends, because Trump knows about scientific stuff, apparently, like you said.
Yeah. Oh, he knows there's a lot of stuff that's been withheld. When you have the perfect example, the U.S. Patent Office has well over 3,000 patents that have been seized and put into the drawer because they're free energy or they're going to have something to benefit the planet. And the Patent Office doesn't want that to happen, right? So that's kind of the conspiracy that we're facing here. Getting some of this great tech, out. So
what's cracking with did Ben leave or he left?
Ben just disappeared. I don't know what's going on with Mr. Ben. He just kind of disappeared. And then Bernie had to go run an errand with his mother, so he'll be back in a little bit. So
I'm still here. I need to run an errand as well. I need to go pick up my kids. So, but I'm listening. I'm still on.
Yeah, I'm just gonna grab something to drink. I'll be back in 30 seconds.
Yep, no problem. Maybe I'm going to show that video again. We're talking about at the beginning of the show Neil deGrasse Tyson had an interview with a physicist talking about the electron. Now, we also know that Nikola Tesla denounced the electron. He didn't believe the electron existed. So this kind of ties into what Tesla was thinking. This guy actually gives a pretty good depiction of what the electron is. So I'm going to show that again. Just bear with me here for a second. I'll do the screen share. All right. And the caption is, do electrons really exist? Okay.
Sounds stupid, but I think it's a meaningful question. Do electrons exist?
Now wait, is that a science or a philosophical question?
Well, because
Natural philosophy.
as I understand it, we have never measured the size of the electron. It is smaller than the smallest capacity we have ever conjured to measure its size.
Okay, I got to ask you a preliminary question. How truthful do you want me to be?
I love it.
Okay, give me what you say in the back room. In the back room with the cigars.
First lie to me. Then tell me the truth.
Okay.
The lie is
Yes.
what is real is the electron field. And little vibrations in those electron fields show up in our detectors as particles. So it's not that we haven't measured the size of the electron, it's that there is no such thing as the size of the electron. The electron is a vibration in a field. It can have different vibrational wavelengths.
And it shows up as the particle.
Yes, that's
Oh my
right.
God.
Yeah, that's right.
I mean, it comes to the party that way, but otherwise it's not.
Yeah.
Okay, that is
wait.
so trippy.
Wait.
That is so freaky, man.
Wait. So
you and
can't-
Einstein both were bothered by this.
I am very bothered by
you-
it.
yeah.
Wait, so you cannot measure the electron in its wave state to be a particle, because the act of measuring it turns it into the particle.
The way that we usually measure things, you say, where is it? And you get a little track in your particle detector because you keep asking where it is, and you always get a definite answer to the question, where is it? But when you're not asking that question, it's spread out all over the place.
Let me ask you a blunt question, which sounds stupid, but I think it's a meaningful question. Do electrons
There you have it. So the electron is not a particle. It shows up in it shows up on the detection devices that they have as a particle, but it is not. It is a coherent field of energy. And this is what Tesla was talking about. It is not a particle. That's why he kind of denounced that the existence of an electron. It is just a coherent field of energy that makes up, when we see it on a detector, it's depicted as a particle, and it's not. So, yeah, really interesting. I saw that clip and I figure, okay, I got to see this, and then I got a very good, interesting answer to that question. So that's why I wanted to post that tonight. So, yeah. It's kind of surprising that something like that would show up on a Neil deGrasse Tyson. I'm not a big fan of his.
Sounds.
You're breaking up, Lulu. Your voice is all choppy.
It almost sounds like the description.
Say that again.
I said the description of the electron. It feels like it's like a membrane, and then when you touch it, then it all conserves, the power of where it has the most mass, and it collapses into where the electron. But otherwise, it's like an energy bubble,
Right. It's a coherence of electrical and energy. I'm trying to find the right word to describe it. It's just an energy field. It's
the secondary effect. It's a secondary effect of a virtual particle. Is the way.
You could call it a virtual particle, because when we detect it, it looks like a particle, but it's not a particle. It's just a field of energy, right?
Yeah.
So.
Well, Bernie seems in trouble with YouTube and all that.
Yeah, they're screwing with his channel again. Looks like. Yep.
Man.
Yep. Yep. Oh, well.
But yeah, the for the electron, you know, the Pauli principle that says that two particles cannot have the same state or the same position.
Right.
Well, I mean, okay, the game is over now. Montreal won 6-3 against Washington.
Oh.
But the Pauli principle says that two particles cannot have the same position or the same state at the same time. Two fermions, which electrons are. I'm trying to understand this Pauli principle because I want to integrate it in my simulator, but my simulator needs to have fundamental rules that apply. I don't want to start patching the simulator with special cases and a little bit like quantum dynamics is right now.
I'm just gonna scoot up for a quick smoke, so Lulu, jump in there and knock him dead.
Otherwise, I'm gonna talk to myself.
No, I'm here. I'm here, but I'm picking up the kids, so I'm in the car, but I'm here.
Oh, okay, cool. Yeah, all right. I should. So yeah, I remember the force field I was talking about. I applied for this year for the Tech Connect conference.
Yeah.
So it's positive. It should work, but it needs to be tested because of the large factor I just discovered that pops out of nowhere, the C-square factor. So that means it's definitely I don't need the petawatts, the petaamps anymore of current to create a force field. I need something much smaller than that, and but it needs to be tested. That's my best advice. But it is possible, but we don't need that amount of energy just because the theory says so. Because the theory is completely wrong and misleading, so we need to test it. So it's definitely possible. So it's the last time I'm gonna rely on the theory if I want to look smart, you know. Next time I'm gonna test it first, and or find a way to test it, and try to look smart this way, you know. Just if I present on something that is based on the theory, I most likely will look stupid, and so I need.
No, you only, I think that like you present it, but the theory you link it at the end, you know, to prove your point. Do you understand? Yeah. So that way you don't lose from your equation, you know.
Yeah. Yeah, exactly. It's kind of a mixture of both. You know, you need because that's the problem. The problem is that the theory controls the experimentalist, and the theoretician says, "Oh no, you can't do that because blah 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 is too weak. You whatever you're trying is too weak." But you never know unless you try, because there's too much theory. It's been 100 years. He had the Maxwell equations. The last theory was based on the Maxwell equations, and everything else was theorized, and nothing was experimented since then. I think that's pretty crazy. You know, we need to experiment a little bit more fundamental physics.
You know what
You have
the cool stuff is? Not the like they did experiment, but not digitally. They had all sorts of tools and things, that they uh, uh, derived, like their mathematics and their physics, and like I'll tell you simply on one thing. We were talking about time dilation. uh, uh, we modern day we use cell phones, clocks on the walls, this that, but they use sundials to really and like the shadows of the moon to actually give time what time is. So if we want to compare to like a computer system, or like digital system versus the real, you know uh, uh how much an hour, and then compare it, because one digitally cannot, they cannot, like, one can't eavesdrop on a sundial, that or but if if you look at the clock on your phone, it timestamps it. Like everything collapses when people look at it, and time is one of those things. But if, let's say, we're in a room and there's like 10 of us, and nobody checks the time, the time is like the electron. It's like it's a field of its own until somebody checks it. Then it collapses.
yeah.
Yeah, and so imagine, how many times does an hour people, the population checks it. So it's really well documented. What a digital hour is worth, but a rotational hour, of the Earth has a different measurement. It will not match up.
Yeah, exactly. I mean, if experiment says so, then so be it. We need to rewrite our textbooks, quite simply. It's very simple. Um,
We need to show them, not rewrite, because like, you have to show proof,
yeah, but
in order to.
that's the problem with the colonel that we saw in Austin. Um, he wa- he he's doing what the PhD is telling him to do. You know what I mean? Because he's a mainstream physicist, but I'm saying the mainstream physicist is not right. So he's kind of he hesitates, but he sees my experiment works. I send him an email, so he sees very well. It's very clear that my experiment works. So so I don't know what's gonna happen, but it's hard to explain. It's hard to explain to somebody you see every year for 2 or 3 minutes that mainstream physics is not correct.
I wish he would watch the show. Then he would
Yeah,
kind of understand that, you know what they give him as raw data, like, or is different than like the equations that
exactly.
they go with. It's There's a fluctuation. It will never match up. It's
Yeah,
not it's not about not matching up. It's just it's going to be read in two different languages. You know, it's like two different timelines.
yeah,
And how do you explain that to was he a colonel?
yeah. He's a colonel.
Well, I mean, he's a, like a military guy, not a science guy. You know, like,
Yeah, but he studied in computer science also,
oh,
so he has a minimum in science.
okay, then he should completely understand
Yeah,
what you're telling him about the force field.
yeah.
I
But
mean, they should be interested in this. It's like, like, you slow down any object in the sky. I mean, like,
actually, I literally create an acceleration vector force vector, so that's gonna deflect projectiles coming at you, and the acceleration vector is stronger by the c² factor that I just mentioned earlier. So that's the cool thing. You have a small time dilation effect, but a large acceleration factor. The resulting acceleration factor vector is stronger by c². So that's the cool thing. I think it's freaking awesome, man. It's like really cool, and
I wish they would take it. Like they would give you funding for it. Can you imagine like all these things that go at super fast speed in the sky, and we can't get like quite a good image sometimes, but like your thing could slow those things down so we could actually see what they are.
yeah,
Like it doesn't have to be just for deflecting something, but it could be slowing whatever it could cross path with your force field.
yeah, um, yeah. I mean, if we can levitate and have a force field at the same time, then you can travel fast. The projectile is not necessarily a projectile from a gun, but like it could be like it could be a bird, or it could be another vehicle that is flying so fast that it's gonna absorb the collisions as well. So that's a cool thing. You can create like a bumper, a virtual bumper. You know what I mean? So, um, but yeah, I'm really happy, man. It's like the crowd is not that big tonight, but I couldn't be happier.
Yeah.
uh,
Yeah.
All those people have missed something good. Don't forget, all these shows are posted at Faraday Research under the live tab. So if you do miss a show, or you got to leave early or whatever, don't worry. The shows are all posted at the Faraday Research YouTube channel. So it doesn't matter if you don't even have to be here on the night of the show. You can always go back to the show a day later or whatever is convenient for you. So that's the beauty of the internet. So all our shows are all recorded. So yeah.
no, it's the Oilers are playing. That's Bernie should be way. Bernie, I bet Bernie is watching hockey right now. That's why he's not. He's not
No,
there.
he had to go drive his mother somewhere, so
Okay.
he'll be back. Hopefully. And Ben just kind of disappeared. I don't know what happened with Ben. He probably fell asleep or something. But even Nathan, he did a couple of really good shows this week as well. You can check out Old Man Builds, and also Philip's got his Patreon. I'll put that link in the live chat so you guys can check out Philip's Patreon, and you can support him as well. So
Yeah. So if you want more historical news, guys, then help me out. that would be appreciated. Thanks.
yep. So
And
there it is. There.
don't hesitate to spread that video around. Because
Yeah.
I
Share the
challenge
video.
anybody you wanted me to challenge. I don't care, because I know they're all wrong, including Salvatore Paez. That's his name. Jack Saffardi. Yeah,
Yeah.
Jack Saffardi or whatever. I don't care. Or
Bunch of schmucks.
yeah.
I just
Canada,
like, I don't know. I don't like him for his science. I just like watching him because everybody is schmuck.
yeah. Yeah, he's funny with that. But he's apparently he's a good guy, Jack Saffardi. So
Yeah.
I don't have anything against him. But
Yeah, I think some of the theories that a lot of people have been working on are making it a lot more complicated than what it is. I think gravity is actually one of them. I think gravity is actually a lot simpler than you know that science wants to make it out to be.
Yeah, exactly. It's very simple. It's not graviton, it's not space-time curvature.
No,
It's just the time dilation differential. That's all it
yeah,
is.
yeah,
Times c squared.
yeah. That's right. That's why they say you can't exceed the speed of light because the mass gets so big, the ship you're in would basically get flattened, right? That's
Yeah.
what they say. But that's part of the science to come up with a novel way of protecting your ship and being able to go beyond the speed of light. And fold. They call it space fold, or going through a wormhole can maybe propel us through that barrier where doing an actual linear travel at the speed of light, we might not actually have to do that anymore. So
Yeah.
yeah,
Um,
it's complex stuff. It's going to take a long time for us to figure it out unless they've already done it in black projects, which is a pretty big possibility that they have done that. Some stuff is coming out of the U.S. government saying that they've actually achieved time travel. So if that's true, if there's any truth to that, then obviously there's some pretty smart people out there that have come up with this stuff.
yeah. Well, I'm not sure. I'm not. It could be. We have to be open minded to these disinformation campaigns also. So maybe some stuff is true, some stuff is disinformation. But
Yeah,
their goal, I think, their goal is to confuse people.
sure. Why do they come up with such complicated theoretical mathematics that the average Joe Blow is going to look at it and go, I don't know what the hell this means.
Yeah.
You know what I mean? But to explain, say, like gravity to a layman, you have to talk in regular English that people can understand the concepts of it. But obviously, academia won't do that. They'll make it look as complicated as possible.
Yeah,
Just
exactly.
right.
Yeah.
It's like,
They want the. Yeah, that's sad because it's the all the groundbreaking stuff was made before the Nobel Prize and before the.
I think so too. I think everybody, who's into this kind of stuff, I think Eric Dollard said it right. He says, if you really want to understand electricity and all this stuff, you have to go back to the founding fathers. Okay?
Yeah.
Faraday, Maxwell, Tesla, Steinmetz, all these guys. You got to go back. You got to go back and learn what those guys were doing. Because back then, they had nobody to really hold them back. Well, Steinmetz had some suppression in Tesla. I think all of them did to a point. But I think those guys were really groundbreakers in a lot of aspects.
And they didn't have the computers we have these days.
Right,
Also.
exactly. So you got to think, these freaking guys were crazy smart.
Yeah, definitely.
They were crazy smart.
Yeah.
Like, you could put those guys up with some of the best theoretical physicists of today, and those old guys would probably still smoke them. They would. I think they honestly would. Because, perfect example is Faraday, right? He did actual experiments, did very good lab notes. He documented all this stuff. So he was able to get a very solid Faraday laws theory on paper with lab notes and experiments to back up those theories, right? So I see a lot of theory going on, but I don't see a heck of a lot of experimenting going on. Maybe there is, but I'm sure not seeing a lot of it. You know,
Yeah.
you know what I mean? Like the theory and the experimentation, they go hand in hand. You know, your theory means absolutely nothing until you can actually make a physical thing to actually show the theory. And that's what Faraday was able to do. Faraday was actually able to create the experiment to back up his theory.
Yeah.
And that's where I think Einstein kind of lost a lot of traction with a lot of people. It's because, okay, yeah, he did do some experiments, but not as much as he should have for the big claims that he made back in those days, right?
Yeah.
So, and half of his theory wasn't even his to begin with. You know, that French physicist and Heaviside and all those guys, he took all their stuff, plagiarized it, and threw it in a new package called the theory of relativity, and says, yeah, I'm the smart guy.
Yeah, he took all the credit for other people's work.
Yeah, exactly. That's exactly.
And more than half of the general relativity doesn't work because general relativity was made to work with the solar system. Because back in the days, they thought the universe was at the size of the solar, not really bigger than the solar system.
Yeah.
You know, so and then they saw that the universe was much bigger than that, and but now his theory fell apart because it didn't work anymore. So they had to invent dark matter and dark energy to plug it in to make
Right.
it work.
But you know, he contradicts himself because he didn't believe in the ether theory. Well, where the hell's the energy coming from if there's no ether?
I know what he's saying. I know he's people don't. Yeah, he says there's no ether, and then he calls space time fabric. You know.
Yeah, space-time fabric.
So it's not an ether, but it's a fabric. Then make up your mind. You know.
Yeah, it's like, well, fabric pretty much says that's an ether. Fabric, ether, same thing. Holler. You know, I'm not a theoretical physicist, but I can pretty much figure that out on my own.
Yeah. Well, what do you think? Why do you think no theoretical physicist comes to your show after the all the calls I made, the invitation I made? No theoretical physicist is showing up in the epic chat either.
Yeah.
No, nobody wants to admit that the whole what they studied for so long is completely wrong.
Yeah, because like if you look at the theory of relativity on the graph, right? You know, linear. It's in a linear plane, z and y. Okay. Well, he's missing the whole negative energy spectrum. He's only got one component of positive energy going in this direction. He's got nothing going in the negative direction, and also below the scale. He's missed 3/4 part of the thing. It's only one layer of space-time that he's talking about. It's one layer. Well, on the graph, I could see 1, 2, 3, 4. Where'd the other 3 go?
Yeah.
He's not even talking about the negative energy side. We know it's there. My experiments for the last 8-10 years have proven that there's negative energy. So if he's saying, oh, there's dark matter and all this stuff, well, okay, that's negative energy. Hello. and 2, that negative energy has to be in some kind of medium. Well, that's called ether.
Yeah.
If he, you know, like
I know they're messed up in the head, that's for sure.
Yeah, it's just retarded. Like they think, you know, at this day and
after
age,
after 100 years, that's all they can come up with, you know.
Yeah, exactly. And this is the best that academia can use, like actually put out. You know, it's like I don't know, government. I think you're not really getting your bang for your buck there if this is the best that they can do.
I know.
You know? Yeah, somebody's getting screwed here.
Yeah. I'll send an email. I already sent an email to Donald Trump about the screw up in theoretical physics. but he didn't really talk about it publicly.
I think it's a lot more than a screw up.
Yeah, Trump really hates getting screwed up, so I know what my main next message will be to him. It's about getting screwed up. No, he's gonna listen to me, you know.
Yeah, he's not getting what he's the best bang for his buck, because if he's spending all this money, I would surely want some advancements. And if they're all being hidden in black projects, well, that's one thing. But if I were like saying, like, okay, if I work, say, for a car company, all right, and I said, okay, guys, we have to make a car that can do 400 mph, okay, and you give them all the funding to do it, and they can't get the job done, well, guess what I'm going to say? Why should I give you more money if you can't do it? I'm giving you all the money in the world to make this happen, and you're not making it happen. I'm going to pull your funding.
Yeah.
The same thing with these institutions out there.
Yeah. Yeah, exactly. So
yeah, some pretty wild stuff. Well, a lot of things going on right now in the world with what's happened with the UFO thing and the free energy thing, and this thing coming out of Washington about Donald Trump's uncle, that he had devices that he was working on some free energy, and they also made the claim too that they also have created time travel. And that was the big one. Time travel. They're actually admitting this. I'm like, wow.
Yeah, time travel in the future is definitely possible, but in the past, maybe it's limited to reversing the aging process of your body or something like that. According to that's what they said. That's what they said, but I don't think you can go back in the past, like in Back to the Future, and start messing around with your parents.
That'd be great if I could go back to the age of 25. That'd be beautiful.
Yeah, of course. Yeah.
Wake up in the morning and ready to go. Not wake up in the morning, you're like, oh.
Yeah. Man, when I was, in Quebec, the pre-university years, it's in something called Cégep. When I was at Cégep, I was competing in martial arts at the North American level, so I was not even training every day. I was just training regularly, but at the time of the competition, I was eating a lot of spaghetti because it was the carbohydrates. It would giving me a lot of energy.
Yeah.
And then I was all primed up for the whole weekend.
Yeah.
And I apparently it worked fine, but these days I need to train like 2 times. I can't even do the kicks I used to do when I was younger. I was able to do like spinning heel kicks and all that. I'm trying that right now. I'm getting dizzy.
No, I'm not laughing because I know. Yeah, it's the same thing with me, right? Like I was younger. I was, I go to Canada's Wonderland and go on all the roller coasters and just have a ball, right? And then I took my daughter there. It was a year or two ago to Canada's Wonderland. I went on one roller coaster and it friggin' screwed me up. I couldn't handle it, man. My head was just spinning after that.
Yeah.
Oh my god.
Yeah, it's crazy.
And I wanted to go on the rides, but my body's saying, So,
yeah.
The joys of aging. But yeah, that'd be one cool thing if you could do time dilation and wind back the clock on your body. That'd be great. I'm all for that. For the good health aspects. But
I'm pretty sure that they'll find some.
Oh yeah,
they'll be able to rejuvenate your body biologically. But I think they found the gene responsible to age the cells,
right?
To for the cells to get older,
right?
Because that's the idea. We need to die and get replaced by our kids, because and so on. But that's the logic of human nature. But
Well,
of
we all
human
have
nature.
we all have an expiry date, right?
Yeah. But I think they said that in this age we'll be able to find a cure for and not aging anymore. So we'll be able to live forever, man.
Well,
Just
I
like
don't know.
Highlander.
Yeah, but would you really want to live forever? Like
Yeah,
even
why
like
not?
even like 100 years, I'd be like, man, I'm tired. I don't want to work anymore. I don't want to work anymore.
Yeah,
I'd rather
yeah,
die. I'd rather die and be like reincarnated and just start from scratch again.
yeah. My mom says the same thing, but me, I don't know. I don't mind. Don't mind living forever.
Well, okay.
Unless I accidentally die, but
Yeah. Well, I guess your chances of having that happen go up greatly as you get older, right?
yeah, exactly.
You're more prone to having bad stuff happen.
Yeah,
But yeah, time travel is a really cool thing that I've always had an attachment to. I always love talking about time travel. I'll talk about that forever. That's one of my big interests. Time
remember,
dilation.
remember the movie, one Star Trek movie. They were time traveling in the past, and they had to travel around the sun a couple of times to around the sun to time travel in the past.
Right.
I think that's what general relativity predicts or something like that, or
Yeah.
whatever.
Well, they say to travel through space is to travel through time.
Yeah,
So that gets into okay, if we can go through a wormhole or a warp where we can jump time to basically skip the lines of time, right? So if that's possible, then it would make it a lot faster, and you would still get the same effects. The problem is you travel out and you come back, and then everybody here is 70 years have passed, right?
yeah,
Depending on how fast you're going. So that doesn't really work too well, especially, you leave the planet and then you come back and all your friends are all dead. Everybody's gone, your family, everybody's gone,
yeah,
right?
yeah,
But if you
yeah.
could
But
time travel,
that's if you time travel in the future. That's what's gonna happen.
yep. And then if you come back and you interact with the people, do you create a paradox,
Yeah,
right? And is that paradox going to be a positive thing for the upcoming future, or is it going to do something wrong, right?
yeah.
So,
Uh,
So what was Pauli's principle? Like two things cannot exist in the same place and time.
yeah, two particles cannot share the same properties. So,
So
but yeah,
if
you can have two electrons with different spins at the same place. You know, as long as they don't have all the properties similar.
yeah, definitely one of my big things. I've done a few experiments with time dilation, and the one that Bruce De Palma did with his rotating magnetic field. So, if you spin a rotating magnetic field at high speed, and he put analog clock on the axis. So whatever shaft or you're using for the magnets to rotate on, if you put a clock on the end of it and you speed that up to high speed, high velocity, he said he was able to slow down the clock. Time
Yeah,
slow.
yeah, it's definitely happening. Yeah, you're gonna shift either speed it up or slow it down, but depending on the direction of the spin.
Right. So I've done that experiment. I've spun my Bruce De Palma end machine at high
Oh, you
speed.
did it?
I've done it, and I did notice some weird anomalies with clocks.
Oh
They
yeah.
start they start going out of sync.
So you were able to spin it fast enough to measure
Yeah,
something?
Yeah, I was able to get one device I made there a while ago. I got it up to about 6,000 RPM. A very strong fishing magnet. They, could lift like several hundred pounds. And I was also hitting it with some high voltage on the shaft itself. And I did notice some interesting anomalies with clocks in the room. They were all going out of sync. They weren't staying, on the same timeline. So
Yeah,
I'm not sure if that was just coincidence or actually was creating some kind of effect like that.
yeah, yeah. If you're interested, I'm trying to
Now
maybe
I was also getting the effects. It didn't matter if it was an analog clock or digital. It didn't matter. So
maybe you know what I was thinking of calculating. I'm trying to find a solution to test the force field using time dilation, but using an electric current. But the problem with the electric current is I need to integrate the gravito-magnetic permeability in my equations so that this way I'll be able to predict the exact same thing as I did with my liquid metal vortex.
yeah,
Um, but anyway, maybe next week I'll have a solution. Maybe tomorrow, every time after your show, um,
you come
the,
up with stuff
the,
after.
yeah, I discovered cool stuff, So
Yeah,
right now I'm a little bit tired, but I'm sure tomorrow when I wake up, I'll figure something out.
yeah. Usually do that during your sleep.
Yeah, exactly. You sleep on it and you wake up with the answer.
Yeah, some ideas come up. Yeah, get your download and yeah.
Yeah.
But what I found,
McDavid just scored a goal,
oh yeah, what I find with time dilation, the larger the magnetic field rotation, actually will determine the amount of dilation. So the bigger the field that's spinning, the better. Now I also
Yeah. But just
now
because the energy and density increases
right
and
now
they
the other thing I found out too that was important is in the space where you're doing the experiment. If you do it below the ground, say like in a basement or whatever, that field gets confined in that space. So you can actually enhance the effects by being in a closed space,
yeah,
surrounded by concrete or whatever. You can confine that electromagnetic spin in that space. So I find that the effects are actually better below the ground than above the ground.
oh yeah, interesting. Well, I mean, below the ground,
You're confining that magnetic field because if you're surrounded all by concrete from the basement, those fields can't escape, so they stay confined in that space, and they get, they'll end up in that spin in the wake and start creating vortices, and you've trapped everything in that space. It can't go anywhere. It's being held, right?
yeah,
So
yeah. Um, well,
I have a theory, like, or an idea. What do you guys think if we send up like a DNA, onto the ISS? Aren't we quantumly entangled to our DNA? Wouldn't What effects would it cause on us when our DNA is experiencing microgravity?
yeah, well, this
Different
yeah,
time.
no, it's funny. It's funny you said that because they have found a difference with the astronauts that come back. There are some anomalies with their DNA has changed.
oh yeah,
So yeah, there is some theory on that. Apparently, there are some physiological changes that happen to the body when you're in microgravity. Then you come back, and then you're not really the same.
Remember the astronauts that were left for like 9 months in space, and they didn't want to pay their salary, but Trump covered them anyways. But yeah, it was kind of
that's kind
sad.
of
Yeah,
they would actually chip them on their friggin' their living, being trapped on the space station. Like, give me a break.
yeah.
That just shows you the brain work coming out of NASA.
Yeah, that was NASA responsible for that. They didn't want to pay their salary for 9 months. Are you kidding me?
Yeah, that's a joke.
You know, you work all your life to get there, and you treated like a slave like that.
I know, it's stupid. And NASA should be ashamed of themselves.
Yeah,
on several fronts. Yeah.
Yeah, NASA is all fully mainstream, anyways. So
it's really kind of lost its credibility, and they're just a money pit, and they don't accomplish much. They haven't done any space flights since the shuttle got grounded. Like, what have they done? Send up a couple of satellites and a couple of rockets, and half the rockets, when they go up, they freaking blow up anyways.
Yeah.
Guys, like, they have other cool projects, I mean, like, they still do the Voyager monitorings, the like the Deep Space Network.
But
like, they're not just what I mean, there's more to it.
Lulu, I know you're trying to defend him, but let's face the facts here. You know how many billions of dollars that they suck out of the government? They're not getting their money's worth. They should have a base on the moon by now. It's not happened. The last rocket they sent up there to the moon, guess what happened to it? It flipped over when it landed. It flipped on its head. It's totally inactive. What a joke. Like, they, and they said they went to the moon in 1969. I don't think so. They didn't. And we got like cell phones that have 50 times the computing power of the Apollo 11. Give me a break. They never went to the moon. That's the biggest farce ever. And I've seen a video of Stanley Kubrick, the guy who did Space Odyssey and 2001 and all that. He admitted on camera he was part of the hoax. He filmed the hoax. I've seen the video. He admitted, he goes, the Americans never went to the moon, ever.
Yeah, but even if they went to the moon, I'm wondering the little craft they were in when they landed, but that shuttle, it has to go back to the Earth, and they didn't really talk about the voyage back to Earth. You know what I mean?
Yeah, they never went to the moon. I'm totally 100% convinced they didn't. The whole moon landing was a hoax, completely.
And if you look at there's a picture of Armstrong or some astronaut walking on the moon, and there's a flag, and the flag has no shadow. It's like it has no shadow. It's really weird.
Yeah. Well, the other thing too is watch the interview of the Apollo 11 astronauts after they got back to Earth. Watch their demeanor when they were in that meeting. It looked like they all came back from a funeral. They looked like they didn't want to be there. They looked like they were sad. It was like you could tell something was not right at that interview. They looked like they were like, don't want to be here, kind of thing.
How come we cannot use a telescope, aim the moon, and see if there's really a flag on the moon or not? Why nobody ever?
Well, I'll tell you right now, they ain't gonna find anything because there's nothing ever been there.
Yeah, I know,
never
but
went to the moon. No.
I know, but why can't we just do that? I think it's very simple, and the telescope are powerful enough to see the surface of the moon.
Yeah, it's kind of funny. As like goes back to old George Carlin joke. He goes, "Making stuff in America, we can't even make a friggin' VCR. It's all jumped by the Chinese."
Oh yeah, another
I
joke
mean,
was
there was a documentary or somewhere somebody one of the astronauts said something like that there were other species on the moon, and they asked them not to come back until they did, like, they gave them a list of things until humans achieve that, then they're welcome on the moon. Other than that, they're not. So, you know,
I don't
yeah,
know.
they
I
got to
still
them. But
from
why
all the
can't
evidence.
we get there again? Maybe we're not
No,
welcome there. You
no.
know?
I think, and one of the most stupid excuses that I heard was why, they're asking a NASA engineer, why haven't you guys gone back to the moon? He goes, we don't have the technology. We lost it. How can? Wait a minute here. How can you lose technology? You only get better. How can you lose it?
yeah,
Like, it doesn't make any sense. Their story does not cohere. It is like,
yeah.
I couldn't believe I heard that. And this is coming from a NASA engineer. And he goes to, oh well, by the way, we still haven't figured out how to get through the Van Allen belt without getting fried. Okay, he's admitting this on camera that they haven't been able to get through the Van Allen belt without frying you. You know, if it's, the amount of radiation going in outer space, if it's as bad as they say it is, then obviously it's like, well, you might as well just shove your head inside a microwave oven and turn it on, right? If you're going to get fried, why would I want to go in space knowing that I'm going to get fried going through the Van Allen belt? I'll say,
Yeah.
you know what? I'd rather stay on the ground.
Yeah.
So, yeah. What a big hoax! I just laugh at the moon landing thing. It's just, there's so much wrong about it in every way, shape, and form. And if it's NASA, well, that even makes my case even that much better, because NASA's lied so much about so many things on so many fronts over the past 60, 70 years. Is crazy.
Yeah.
What a joke. And even
Yeah.
Edward von Braun, the guy who basically started NASA, right after the Apollo was done, he left NASA. He didn't want any part of it. He didn't even care about making rockets anymore.
Yeah.
You know what I mean? It was like he just threw his hands up in the air and left. Worked for a division at Lockheed Martin for the last few years of his life, and that was pretty much it. He was done.
It's pretty sad that all the brain power we're wasting, all these smart people that work for NASA, and they all end up lying.
Yeah, it's all garbage. They
Yeah.
don't want to show anything. Well, if you're going to make something and you don't want to show it, what's the point? It just doesn't make sense to me. It's just, there's no logic in how they're doing stuff. For as smart as they are, I don't see a hell of a lot of logic going on.
Yeah, I know. They claim they all claim they're the smartest and blah blah blah. Yeah,
With all
the string theory, whatever nonsense. I don't care, but
and
they end up lying. So
yeah, and they have the tools to lie even better now. Look at this AI stuff coming out now. I could come up with an Apollo mission right now on the computer and post it and say, "Hey, Mike Faraday research just went to the friggin' moon tonight." I could make one up on friggin' AI and say, "Yeah, Faraday research is on the moon." Like it just, like today, for them to fake a mission to Mars and fake a mission to the moon would be so easy to do now. Like,
yeah,
like we have all the tech to fake.
Well, yeah, because now we've got like infinite amount of storage. Back
Yeah,
then,
no,
like
no, but
the programming. It like
yeah, it's like I could go on an AI program tonight and fake Faraday research is landing on the moon. I could do that very easily. I could even make myself in a spacesuit and have my Faraday research flag going into the moon's surface, and it would look perfect. It's
That's
hilarious. It is so freaking hilarious, but it's so true. Because now we got the tools where we can fake shit.
Yeah. It's the same thing with the. Did you know that the Stonehenge stones are fake? They're not truly from the medieval times. They're from they it was built in 1920 by some people to attract tourists,
Right.
or something like that.
no, they restored it but like no, it's really old, like really old.
They
Yeah, I think
you
it's
restore it. Why would they want to restore it? Usually, old stuff you're supposed not to touch it.
I could make Stonehenge, just give me
That's not true. You try to restore things like everywhere.
No.
You don't leave it. Like you.
the 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 moon landing is about as fake as this piece of cheese that I'm holding up right now. Oh man,
That's funny.
I think I'm going to do that. I think I'm going to make an AI, a Faraday research, going to the moon.
And you fake the ship that propels yourself in the atmosphere and all that. That would be
Yeah,
funny.
yeah, and I'll take my chinchilla with me. My chinchilla,
Okay,
my
but
chinchilla will have a spacesuit.
question though, seriously, on like the analog part. Okay, like the how this is imaged. Well, when something is imaged through a lens, is different than when it's generated from you know the computer itself, like the AI itself, because it's not deriving these images from a lens. So there is a code for that, on the back end, like behind the image, the numerics. Well, the lensing part that would tell you if this is legit or not, on the video. Like,
Yeah, well,
so
this guy, I've seen an interview with this guy who's a audio and video engineer, and he took the original cast of that moon landing. He put it through the AI system, and it said 100% fake. Yep,
it says
100%
an
fake.
AI that that has not indexed images through a lens, or does it have? Do you understand what I'm trying to say? Like, it just depends on the AI. Is it a text based, or is it like text visual then based? Well, these visuals,
Both.
like, where is this information pool coming from?
Right.
So it has to like be like a base code for the primary information that it compiles into creating these artistic images,
Yeah.
or like AI videos.
Yeah.
But
I don't care what anybody tells me. I've seen enough interviews with experts that analyze those videotapes, and they're pretty much unanimous that it was faked.
I think I know what happened to Ben. Ben got paid by the CIA tonight, so he would turn his back on us.
He got paid by the CIA.
Yeah.
He's a sleuth. Ben's a sleuth. He's the infiltrator.
Yeah, exactly. He infiltrated, and now he said, "Okay, tonight's the night." So,
That's hilarious.
yeah.
Oh man, I want to do that. I want to create the Faraday research trip to the moon. That'd be awesome. If you want to be on the mission with me, Philip, you can come with me. You could be the pilot.
So I have a
Go
question. Why
go
don't
time
why don't we
travel in the
apply?
past.
Why don't we apply for a grant and put all your videos, all of your inventions, and let's get funding and say, hey, like everybody does it, but with a twist that we're ahead of everybody. But now we have a backing, of somebody interested in, and what do we care at the end of the day, whether it goes or it doesn't go? You guys all want a better life, you know? And
Well,
so,
that's what I'm trying to get grants from a long time ago.
yeah, but
That's
let's
why
for
I'm.
real make a proposal and say, we have a good team. We have been dialoguing and podcasting for like over a year, and we have a good group of individuals that have a vision and know more than the academia part, and have already conducted experiments and have already invented things, and
Oh,
so like why wouldn't they be interested in putting this group to a purposeful task? You understand?
yeah.
So why not?
Oh, I just want to add one more thing. I found out an actual experiment I can do with my battery cell that I've been working on there, to find out if actually quantum tunneling actually is happening in my cell. And I found out the way to do it. Know how I do it?
Sure.
Yeah, go for it.
I put it in outer space. If it works in outer space, that means quantum tunneling is happening. So if I can somehow find somebody that has a cryogenic freezer that can go to minus 467 degrees C, and then take a reading of if it's actually producing power at that temperature, it's quantum tunneling. That means it's 0 point energy there. So if there's able to have physical ionic movement through the medium from anode to cathode at minus 467 C, that means it's quantum tunneling. It's 0 point energy. Basically, almost like the
Wow.
Casimir type effect. So
Well,
that's
why
what
don't you use the satellite cubes or something to send it in space? It's gonna be cold there.
Yeah, well, that would be the place to actually prove if there is quantum tunneling happening in the cell. When you go to
Yeah.
absolute zero, where the actual real theory for 0 point energy is 0 point fluctuations at absolute zero, which is outer space at minus 467 degrees C. If there's still energy movement at that temperature, that's 0 point. That's where the 0 point energy came from. So if there's quantum tunneling happening, it would be able to do it at that temperature. So that would be a good test for my cell to prove that there's quantum tunneling going on.
Yeah.
What's the purpose for it being in space versus being on land and putting it, and getting it that cold through
Well,
different?
what it's showing is that the ionic movement from the anode to cathode is breaking through a barrier where there seems to be no means of energy present.
Okay,
So
got it.
at an absolute zero, if there's energy happening at that temperature, that's where that 0 point energy came from, right? 0 point means at zero,
I got it. I
absolute
understand. I
zero,
was
right?
understanding that you are counting on the
It's
exterior.
basically it's it's basically the movement of an ionic flow through a barrier where you think it should not penetrate, but with no power added to it, it's doing it on its own. It's able to go through that barrier with no means of energy. So if there's no means of energy, but it's still making it through, that's what they call quote unquote quantum tunneling. So it's a real effect. And yeah, that would be a really good test if I could super freeze my cell and test if there's anything happening in that state. So yeah, just something that I found out. Thought I'd share it with you guys. Well, we're coming up to the top of the hour. I got to be up early tomorrow. So my daughter's having her birthday party tomorrow, so I got some stuff to do. And I like thank everybody for showing up. Chat was great. Thanks a lot, chat. We'll be going live to air again next week at Friday at 9 o'clock Eastern, 6 o'clock Pacific. Thanks, Lulu, and thanks, Philip, for your great input tonight. Really, actually, it was a really good show. I enjoyed it tonight. We talked about some really cool stuff, and maybe I'll look into making the Faraday research spaceship, and we're going to the moon. Yeah.
All right. Let's do
guys.
this. All right.
Yeah, you're coming on the. Are you coming on the ship with us, Lulu?
Absolutely. Like,
Yeah.
to go without me, you know?
Will you around the sun too to time travel in the past?
Yeah. We'll go to Mars, and we'll walk up to that little rover and we'll give it a kick. Oh man. All right, guys, on that note, have a great night, everybody. We'll see everybody next week.
All right.
See
you.
Take care. Take care.
Good show. Good night.
Good show. All right. See ya.